Hi, now let us discuss about gravitational force and field strength. Now let us read this question. A rocket of mass 2.4 exponent 4 kilogram is traveling from the Earth to the Moon. The mass of the Earth is 6 exponent 24 kilogram and the mass of the Moon is 7.4 exponent 22 kilogram. What is the gravitational force of the Earth on the rocket when it is 1 exponent 9 meter from the Earth? Okay, so let us, all this information I already summarized here. We have the mass of rocket, we have the mass of Earth, and also mass of the Moon. Okay, I put here already. And now is the rocket is traveling from Earth to Moon. So it's like that. From Earth to Moon, the rocket travels. What is the force between Earth and rocket? What is the force between Earth and rocket? Force of Earth on rocket. Okay, so now force between Earth and rocket. So the formula is Fg equal to gmm over r square. Okay, so we use, what do we use? Sorry, again, now we use mass of Earth and we use mass of rocket and the distance between Earth and rocket. Okay, good. Now let's substitute all the values. G is always 6.67 exponent negative 11. Mass of Earth we have, we have the mass of Earth ready. Okay, we have the mass of Earth, the mass of Earth and mass of rocket. So just put all the value inside. Mass of Earth 6 exponent 24. We have mass of rocket 2.4 exponent 4 divided by the distance between them. Distance between them given, 1 exponent 9 from the Earth. Okay, so that's the value. 1 exponent 9. 1 exponent 9. Don't forget your square. Many students forget about square. Remember, you need to square the r. Okay, square the r. For vector, you have square below. Only the scalar quantity, no square below. Okay, so the answer is you get 9.60 Newton. Okay, this one, what's the direction? You need to give direction also, because force of Earth on the rocket, that means towards Earth lah, attract towards Earth. Okay, towards Earth. So just write there. Need to write the direction also. Oh, sorry. You need to write the direction towards Earth. Okay, so just click this off. Towards Earth, to the left. Now, suppose that the rocket is traveling along the straight line joining the Earth and the Moon. So between Earth and Moon, what is the distance of the rocket from the Earth? Rocket from Earth when the gravitational force on it by the Earth and the Moon are of the same magnitude. Okay, so want to find the distance. You want to find the distance rocket from where? From the Earth. Now he say force by the Earth and the Moon same magnitude. Okay, so that means the force. He said the force by the Earth and the Moon same magnitude. That means resultant force 0. Okay, you see, the Earth attract the rocket. The Earth attract the rocket. So this is between F, E, R, Earth rocket. Moon also attract rocket. So this is the Moon on rocket. So we want to find the total force on rocket when the total force is 0. We want to find what? We want to find distance from the Earth. Distance of rocket from the Earth. That means between Earth rocket. We want to find this. We want to find this x. It's given distance of Moon from Earth. Okay, Moon from Earth is r. This one r. Okay, so we have this. We want to find x. Here, how about this one? This one is r minus x. R minus x. Okay, good. And don't forget, for these two are vectors, you must put sign. Going to the right, positive, going to the left, negative, as direction, right? So we start with total force equal to 0 because you say force of Earth and force of Moon same magnitude. When this force of the Earth equal to force of the Moon, so they cancel each other. They cancel each other, so the total force on rocket is 0. The resultant force. Actually, this is what we call the resultant force. The resultant force on the rocket is 0. Okay, so we start from resultant 0. Okay, to the right, we have force of the moon. We have force of the moon. So 4 FMR is positive. To the left, we have FER. We put as negative because to the left. The positive negative just mean direction. Sorry. FER. Okay. So yeah, that's it. So now let's solve the question. Mon R and ER is the same. They're equal. They cancel each other. So use the formula GMM over R square. Here also GMM over R square. So this is between the moon and the rocket. Moon, rocket. This one is between the Earth and the rocket. Distance between Earth and rocket. Okay. We can cancel. We can cancel the what? We can cancel the G because they are common. G can cancel. The rocket mass also can be cancelled. See? So just left with all this lah. Okay, so what's the mass of moon? So substitute the value 7.4 exponent 22. Okay, so substitute the value 7.4 exponent 22. Okay, exponent 22. And then distance between the moon and rocket. Moon and rocket is R minus X. So we put this as R minus X. Okay, square. Don't forget the square. Mass of Earth. What's the mass of Earth? Mass of Earth is 6 exponent 24. Okay, 6 exponent 24. Then the between Earth and rocket. Between Earth and rocket is X. We want to find X actually. So X square. So we got it. Now better actually you just write as a mass of moon over R minus X first. Then only we don't put the value first because a lot of value you need to put inside. So it become messy. So rearrange the formula first. Just put back the alphabet. So put the square at one side. So this, this one just interchange. This one and this one just interchange. And then continue. We have mass of Earth and mass of Moon here. Why we put all the square to one side? We put all the square to one side because we want to square root. We want to square root both sides. So the square be gone. The square is gone. And now only we substitute the value. Just now the mass of Earth. Just now the mass of Earth is 6 exponent 24. 6 exponent. 6 exponent 24 over mass of Moon. Mass of Moon is 7.4 exponent 22. You know why I only write values here? Why don't I start from here? Because if you write over here, then every time you rearrange your formula, you need to put in a value. Then it become like a lot of things to write. Very messy. So just maintain as alphabet first. If you want to calculate, then only you put in the value. Okay. Now our square root. What do we get? We get 9.0045. Okay. Now rearrange. We get x equal to 9.0045. Multiply above. Multiply above. This one multiply above. We get this one lah. Okay, x. So finally we will get and then this r value just now is 3.8 exponent 8. So just substitute the 3.8 exponent 8. So in the end, we will get x equal to 3.42 exponent 8 meter from distance from Earth. That's the answer for part B, 3.42 exponent 8 meter from Earth. Okay, so that's it for this first question. Stay tuned for the second videos.